Lesson 5, Sine Law. Okay, so right triangle trigonometry, so it's just setting up those ratios we already talked about with SOHCAHTOA. So SOHCAHTOA, good important thing, those ratios are only usable for right triangles. Opposite, adjacent, hypotenuse. So hypotenuse comes from the 90, right? So you know that SOHCAHTOA has to be used at 90. If you didn't know that, now you do. Okay? And why sine law and cosine help us get around that. So for example, in each case, determine the value of x to the nearest whole number. There's a lot of different ways I can do this. I'm trying to find x. So if I'm doing x, I have the opposite side and the hypotenuse. Sine x is 8 over 14. So then how do we find the degree? What do? Inverse sine, right? Sine inverse of 8 over 14 will get you the degree measure. 34, yeah, they're around to 35. But yeah, 35. Okay? So this one you can see, this time the x is not the degree. So we won't have to be using inverse. Okay, we just solve. So you set it the same way, but you put it in stuff that you have. So this time I have a degree. Well, my degree is right here. This side is what to that degree? Adjacent. This is hypotenuse. We don't know the hypotenuse. Okay? Now if you're saying, why don't you use Pythagorean theorem? Well, we only know one side. We don't know two. Okay? So we're going to do cosine of 40 is 19 over x, adjacent over hypotenuse. Now it's this little move that you do here when you're solving when the x is on the bottom. You just essentially switch these spots. X goes over here, divide the cos 40 here. So in your calculator, you're going to calculate 19 divided by cos 40 will give you the length of the hypotenuse. Nope, because we only inverse when we're solving for the degree. We're not solving for the degree. If you do that, you should get 25. It said round the nearest whole number, so that's what the direction said. Okay? So that's just the basic stuff for the trig. So now what we're going to do is we're going to talk about how the sine law is developed in terms of how it's applicable to, if you're saying, well, Mr. Baker, you just said that you can't use sine and cosine stuff unless it's a right triangle. True, but there still is a relationship in terms of the ratios we're going to talk about now. Okay? So let's look at this here. So use SOHCAHTOA to determine the lengths of BC. So we're trying to figure out the entire length of BC, so that whole length of the bottom there. So what we want to do is we kind of want to work around to get information that we need. What I mean by that is that you see that with this whole triangle, it's not a right triangle. Do we see that? And so what we did, we drew an altitude down, and we made right triangles. Okay, well, from here, for this guy, we have an angle and a side. If you have two things, that's 2 of 3. You can find the missing sides. Okay? Well, we're trying to figure out DC and BD. What's the problem? Why can't I find DC right now? I know 0 lengths of this triangle. I don't know any of the lengths of it. So I have nothing to compare it to. I have no ratios for it. So what we want to do is, what would be really helpful to find? That right there. Because they share that. So if I find AD, I now have a side to compare for DC. Okay? So what we're going to do is we're going to do our SOHCAHTOA to find we're going to find what the height is and BD, because we need both of them. In this case, yeah, well, the height to be cosine, adjacent over hypotenuse. We can do that first. So we want to find the height first. So we're finding the height right now. The height would be cos 20 equals x, the height we'll call x, over 12.5. And so what we do is we times 12.5 to cos 20. That equals your x. What's that? The answer, yeah, is going to be 11.7. So AD is 11.75. We'll just say 11.75. So it says 3 decimal places, so 746. 746. Okay? And then we're going to do sine to figure out the opposite side, right? Because we have the angle, the opposite side is BD, and that's the same setup. Sine 20 equals, we'll call this one, we'll just call this BD, is BD over 12.5. So we're doing 12.5 times sine 20 is what that bottom piece is. Okay? So BD ends up being 4.275. Remember on these, you need to be in degrees for your calculator because we're using degree measurements. Okay? So we've found all the sides of that skinny triangle on the left. Now that we've found those sides, we can go ahead and do the comparisons or anything we want to find DC now. I use 35 or 55. Okay, it doesn't matter which one. I'm just going to use the 35. Okay, so from here, what is the AD side? Opposite. I know opposite, right? So I want, what's this side? Adjacent. What's opposite adjacent? Tan. So I'm doing tan 35 equals opposite, which is 11.746 over adjacent, or DC. DC is the adjacent here. Yep. Yep. You can't do sine. It'd be tangent again. Yeah, because it's opposite adjacent. We don't know hypotenuse at all, so hypotenuse won't be used here. Okay. So then these essentially switch spots, like I said. So then I'm going to call A just DC, so we know what it is. So DC equals 11.746 divided by tan 35. So when you do that, for DC, you should get 16.775. So the length of BC is that plus this. These two things added together is what BC is. So BC is 21.05. And it was in centimeters. Okay? All right, any questions on that? So what we're going to do is, so let me explain where let me get to the next page here. Okay, so here, there's thrown to you right now. Here is the sine law. It's not three equations, okay? What it is that the proportions of the sine of the angle that make the side are the same. So this is what this means. Sine of A means sine of angle A. Does everybody understand that angle A is right here? Where do you think side A would be? Exactly, BC. It's a side that is made from angle A. That angle A makes that side. See, that angle is what creates the size of that side. Okay? So same thing here. Here's angle C. This is side C. Angle B, side B. Okay? Now the sine law, what it does for you is the comparison of sine of that angle and the side is going to be equivalent to all of the comparisons of A, B, and C. So this is not a 3. You're only going to really use 2 at a time. So this is a little misleading. Okay? What's going to happen in sine law more times than not, you're going to know 3 pieces of information. Because this is not a right triangle, right? So if I say this is 6, this is 7, and let's just say this is 35 degrees. I know 3 pieces of information. I can find the rest. Okay? So, like for example, if 35 makes 7, the sine law will tell me or help me figure out what degree makes 6. What degree makes 6? And you would set that up. We're going to do here in a second. But again, it's not 3 equations. These 3 proportions are equivalent. You'll kind of use them 2 at a time. Okay, so let's go look. So we're going to prove it first, but kind of where it comes from. Okay, so complete the following work to show that A over sine A equals B over sine B. So what they're going to do is that sine A is equivalent to CD over AC. So what they're saying is, see here, sine of A, that's opposite, right? CD, that's CD, over hypotenuse, AC. That's where the AC comes from. AC is also known as, so here's angle B. AC makes side B. So that's what they're doing here. So then what does CD equal? So let me write it back for you here. Sine A equals CD over B. So what does CD equal? How do I solve for CD when I just wrote right there? I want to solve for CD. So I times the B over, yep. So B sine A. You see, I see that? CD equals B sine A. So now we're look at sine B on the other side. So sine of B. Sine of B is what values there? In this triangle, if I'm doing sine of B, we're looking at this one here. Actually, it doesn't really matter. Sine of B is opposite, so what's the opposite side? CD over BC, right? The hypotenuse. In this picture here, BC is what? It comes from A. So CD over A, right? So then, sine B equals CD over A. So CD equals A sine B. I know it's a lot of letters. Hope you're following. But then you'll see we're making the proof, which is kind of neat. Well, if I divide the A over here and divide the B over here, do you see it? If I divide the A to the left, I have sine A over A. If I divide the B to the sine B, it's sine B over B. That's the proof of the sine law. So when you divide, it says divide both sines by sine A, sine B, gives the result of B over, you can do it either way too. I'll show you what I mean. These are both or. Doesn't matter what's on top or bottom. Just sines have to be on top or sines have to be on bottom. But we just proved that. Okay, and then here's the repeated work. This is just the repeated work. It's just telling you that you can repeat the work above to do the C. We're not going to do that just for the sake of time, but you'll get that the C is also equivalent to one of them. Once you get, if sine A equals sine B, and I figure out that sine B and sine C are equal, then they're all equal. Okay, so that's the form. So let's actually do some examples of this. So here we go. So it says triangle AB, some class example 2 is shown. Use the sine law to calculate the length of BC. Compare your answer to the SOHCAHTOA method. So remember that first one we did? We had to do all that roundabout stuff. We had to find the middle. We had to draw an altitude. We did all that work, right? Sine laws that get around to that. Okay? Sine laws that get around that. So it's kind of showing you why we use a sine law. So that very beginning there, that work we did took a long time to do something we can do much quicker. Okay? So here it is. My trigger for sine law is I have 3 things. Okay? And I want at least one comparison. What I mean by comparison is I see that 35 degrees makes 12.5. 35 degrees makes 12.5. The question wants to know what is made for BC. Well, we know BC comes from the 75-degree angle. So here's the hint I'm going to give you. So you know whether to use what's on top or what's on bottom. Are we missing a side or are we missing an angle? A side. Put your sides on bottom. Okay? Or sorry. No, put your sides on top. I'll show you why. So you're going to go sine of 35 makes 12.5 equals sine of 7. So I'll show you. Now I can see it. Okay. Sine of 75 makes side A or BC. So the reason you want to put your sides on top is because see how the thing I want is on the denominator? It's easier to solve it when it's the other way around. Okay? So in this case, I'm just going to tell you to switch it real quick. You can do it either way if you're good at your solving, but this is just a little bit quicker, I think, because you have one thing to do. All I have to do to solve for BC is what? Multiply sine 75. Sine 75 is a value, guys, so that's not like a weird variable, so that's gone. So this is what you have to calculate. You're going to do sine 75 times this in your calculator. That's the value of BC. We know the answer. We already did it, but you should get it. 21.05. What's that? Oh, you good? Questions? We're going to do a couple more. Got 3 more. Okay. All right, let's try part 4. Part 4 is a brand new one. So that one we kind of already knew was going to happen. Okay, let's try part 4 here. Use the sine law in the triangle below to determine the measure of angle ACB to the nearest degree. Okay, so here's what we got. We know that 110 makes 9.4. We want to figure out ACB. So they want to figure out this side. Now here's the tricky part. This is where you got to use your knowledge of triangles. Do we know what C makes for a side? No. So we're actually going to solve for angle B. If I get angle B, then do I know what C is? Every time you know 2 angles in a triangle, you know all 3. Right? Because all 3 have to be 180. Say that one more time. It is. I'm saying, no, I said it is, but there's nothing over here. Right. Okay? Good. So this is an example where you're going to find angle B, then to get angle C. So it's a little bit two parts in one. So, but we know this setup. We are finding an angle, so I want my angles on top. Sine of 110 over 9.4 equals sine of the unknown, this is sine of B, is 6. And we're solving for B here. What's that? You're going to multiply the 6 first. And guys, we're solving for a position and for a degree, so what are we going to end up doing? Inverse, yes. 6, 6. So you're going to find out what this value is. Okay, you're going to find out what that value is. It ends up being 0.5998. Is that right? Yeah. Okay, that's what sine B is. And now what you'll do is you'll sine inverse that. And that'll kick out the degree measure. And so you should get 37. Okay, let me pause there. That's pretty much the hard part. The last part's actually quite easy. Is everybody okay with getting 37 for B? Who's lost? What? Oh, they said you're lost. Okay, so you multiply the 6 over. 6 times sine of 110 divided by 9.4 is 0.598. Sine B equals 0.598, so we inverse sine to get the B by itself, and that gets us 37 degrees for B. So that means this spot's 37. So then our last part, which is kind of easy, we add these two for 147, subtract from 180 to get what angle C is, 33. So 33 is our answer for angle C, which is ACB. Okay, questions or concerns? We got one more. Because these two angles are not the ones we want. There's 180 in a triangle. Right, we add these two, subtract 180 to get them missing. Yep. You're going to do that quite a bit in this section, Kale, so kind of get used to that. Okay, here we go. Surveyor, here's your applications. Surveyor measures a baseline of PQ is 440 meters long, so I'm going to put 440 here. He takes measurements of a landmark R and P and Q and finds QPR to be 46. It's right here. It finds PQR to be 75. Okay. Calculate the perimeter of PQR to the nearest meter. So that means we got to find the other two sides. Here's a tricky thing. Do we know what angle makes 440 yet? But we can get it, right? Because we have 2 of 3 right now. So we can find that missing angle right now. So we're going to do that first. We're going to go 46 plus 75. Because, guys, to use sine law, you need to have one full comparison. If you don't have a full comparison, you can't do it. Okay? 75 plus 46 is 121. 180 minus 121 is 159. Or sorry, 59. Okay, so 59 degrees is what angle R is. Now we're ready to set up our sine law. Okay, so we're going to go. We're finding sides, so we want our side to be on top. So 440 over sine 59 equals sine, let's find this one first. Let's find RQ first. So that'd be sine 46. So RQ we'll say is side P. P over sine 46. And then how do we solve that? We time the sine 46 over. Sine 46 times 440 over sine 59. A lot of calculating in this section. So, yes, this one's 369.25 is what that measurement is. Okay, and they'll do the other one. Same exact setup, but we have sine of 75 on the bottom, and it makes side Q. Okay, so we're going to go 440 over sine 59 equals side Q over sine 75. Times the sine 75 over. That gets you your side. The other side is 495.83. While you're writing that, I want to pause and make sure you're making sense of a couple things here. You should feel good about your answers for two reasons. They're all pretty, and they're in the same ballpark. They're all around 400-ish, but also 75 was my biggest angle, and it made the biggest side. Right? 75 degrees made 495. That's the biggest of all three. Right? The smallest angle of all three is the 46, which made the smallest side of all three. So in terms of your number sense and what you expected, that falls in line. And now you add all three of those for the perimeter. When you add all three of them, you get 1305 meters. Okay, we got one last little piece we're going to do here. Yep.
So when you're looking for the side, the sine is on the bottom, and when you're looking for the angle, the sine is on the top.
Yeah, I would just say whatever's missing that you don't have, put those on top because the variable in the numerator is a little easier. Right, whatever's missing on top because it's just easier to keep your variable on the top. Okay, all right, so extension to this problem in the next page here is they want us to find the area. So what do we need to find the area? Base and height. So we know the base of it was 440. It's not the exact same here, but we know it's 440. Okay, we have P, R, Q here. We know this is the Q was 495.83. Okay. And then the other side was we don't need the other side actually. So we draw this straight down. The point is, now we can just do SOHCAHTOA. Just kind of using all of your stuff together. Now you're saying, well, I don't know how much of 440's gone. Doesn't matter. Because we know this angle measure right here. This angle measure was 46, right? So you have 2 of 3 of that right triangle. Do you see that? Because we need the height, right? The height has to be perpendicular. That's why it's 90. The height of a triangle has to be perpendicular to the base. So that's maybe the part. It's perpendicular. Tangent means touch just once. So depends what you mean by tangent. Oh, I see what you're saying. Is it tangent? No, because this is the hypotenuse.
Oh, right. No.
Yeah, so it's actually going to be sine, opposite over hypotenuse. So you're going to go, this is just regular SOHCAHTOA. This is not sine law. So it's going to be sine of 46 equals, I don't know, over 495.83. So I'm going 495.83 times sine of 46 to get the height, which is 356 is correct. 356.67. So we have our height now. So we go 1/2 base times that height. And that's your area. So we do that. We'll come down here. So yep, 78,500. And then it's cubic meters, right? Because we're talking about, sorry, square meters, because we're not cubic, not 3 dimensions. Square meters. Okay, good. That's it.